Great, thank you, Mark, and thank you to all the organizers for having us here today. We're really excited to be with you to talk about CASIS and the International Space Station, and for all of those that are participating online. So today I'm going to talk a bit more about, or just give you some more information in terms of the incredible science, the technology, and research aboard the International Space Station, how companies are leveraging the ISS, and how CASIS, or Center for the Advancement of Science and Space, how we're creating these economic opportunities, advancing technologies, enabling discovery, and not only driving utilization of the ISS as a platform for innovation, but serving as that central point to pave the foundation for future space stations, orbiting platforms, and commercialization beyond low Earth orbit. So as Mark mentioned, I'm the Commercial Innovation Technology Lead for CASIS, and I wanted to tell you a bit more about the International Space Station first, and then I'll let you know more about what we do. So the International Space Station is one of the greatest human and technological achievements of our history. It is the most complex international scientific and engineering project and the largest structure humans have ever put into space so far. Space agencies from the United States, Russia, Japan, Canada, 11 countries in Europe all came together to build this unique place, demonstrating a convergence of science, human innovation, and technology and research breakthroughs that are just not possible here on Earth. So to put into perspective, the International Space Station is about the same size as a football field and has more livable space than a 5-bedroom house. At 250 miles, or about 250 miles above the Earth, flying at about 17,500 miles per hour, and completing 16 orbits per day, or circling the Earth every 90 minutes. And we cover the planet's populated areas, or 90% of the planet's populated areas. So it serves as our research laboratory that's exposed to microgravity environment, which you've been hearing about throughout the day in the previous presentations, the extreme environments of space. I'm going to get into that a little bit in just a moment. And collectively, the ISS has actually enabled over 2,400 researchers in 83 countries to conduct more than 1,700 experimentations and investigations in life sciences, human research, physical sciences, earth sciences, astrophysics, technology research, and demonstrations. So when you're hearing about, or on the space panel, about the Deep Space Gateway, so the space station was starting to get built in 1998. And since then, we've had about 18 years of continuous human habitation on board the space station, which is pretty incredible. When you hear some of the students that are graduating from high school now, those kids have only known humans to be in space for the past 18 or a little over 17 years, which is pretty remarkable. So in 2005, US Congress designated the ISS to be a national lab. And then in 2011, CASIS, or Center for the Advancement of Science and Space, was selected by US Congress to be the sole managers of the ISS National Lab. And so that's really where, when we came in and were tasked by US Congress and NASA to utilize the space station, or maximize utilization of the space station for the benefit of our planet, and also really to serve as that central point, like I said earlier, in terms of the Deep Space Gateway. What is that long-term vision, going beyond in terms of space station into other space stations and other orbiting platforms? So our mission at CASIS is, as I said, to maximize utilization of the space station by pursuing groundbreaking science, technology, and innovation that's just not possible here on Earth. We're advancing the nation's leadership and innovation and in the commercial space sector, and leveraging this incredible platform to inspire the next generation of explorers and scientists and engineers leveraging ISS STEM education opportunities. And how do we accomplish our mission? We execute our mission by working together with NASA, our service providers, our launch providers, implementation partners, drawing on the results of ISS National Lab science to improve the lives of people on Earth, and providing value back to our nation, and creating new partnerships across disciplines with commercial companies or Fortune 500 companies, academia or academic institutions, government agencies, startups, entrepreneurs, and venture capital. And really trying to drive that demand across these disciplines. And we've focused on 4 key areas, as you see here, which are technology, physical sciences or materials research, tech dev or technology development, which is the portfolio that I oversee, and remote sensing or aerospace technology development. So these are just an example or a list of some of the existing customers that we work with, and by no means is this list complete. It's just to give you a sense of who we're already working with, where a lot of these companies have either flown payloads and investigations to the space station or are about to fly to the space station. And really trying to use this proactive go-to-market strategy and trying to drive this demand. We're really on the front lines working with a lot of these new-to-space customers and users that can leverage the International Space Station. Another point I wanted to make, in terms of just this past year with fiscal year 2017, 70% of the new projects that were selected, or 70% of the 45 new projects that were selected in 2017 originated from new-to-space customers. And 60% of those were commercial companies. So it just shows you that the types of demand that we're seeing, and that's continuing to grow. And also wanted to mention in terms of the value, the impact that we're bringing back to the nation. Since our inception, we've been able to generate over $900 million in terms of incremental projected revenue, where the accelerated time to market is projected to be between 1 to 3 years. And selling into these multi-billion-dollar markets where the total addressable market is around $110 billion. So we're also enabling, as I mentioned before, in terms of working with venture capital, startups, entrepreneurs, we're enabling these innovative startups to get access to the space station. We partner with Boeing and one of the top accelerators and incubators in the country, Mass Challenge, which is based in Boston, and really trying to provide that access for small companies or startups to get access to the national lab and to the space environment, to also demonstrate in terms of their model or what their business plan for their company. So we're seeing a lot of activity there. Also, another collaboration model I wanted to mention and point out, we employ a number of those, and one of those is our sponsored program. So we actually partnered, we're excited to have partnered with Target Corporation last year. And they were interested in tackling cotton sustainability as part of their CSR goals. They were telling us in terms of one of the stats that it takes over 700 gallons of water to produce one cotton t-shirt. And they wanted to see how we can leverage the space station to grow more sustainable cotton, looking at particular areas, if it's with plant sciences, water dynamics and filtration, remote sensing or Earth observation. And this model, these sponsored programs can be applied into overarching, or these, what are these big problems that we're trying to solve around the world, or partnering not just with corporations, but the United Nations with Sustainable Development Goals, et cetera. And I should also say that we just announced the winners for that challenge a couple months ago, so we're excited to see those launch to station pretty soon. As part of the mission, as I mentioned earlier, our STEM education programs, which is called Space Station Explorers, we're really hoping to see how we can leverage the space station to inspire that next generation of explorers and scientists, engineers. And our programs can allow students to talk with astronauts. They can engage in space-based research, design and launch their own experiments with free programs and resources. And also, we're very proud of a lot of the partners that we work with that enable some of these programs, not just in the STEM education side, but with our commercial innovation endeavors. And the rich R&D environment that's on board the space station and the National Lab is only possible because it's made through this unique blend of organizations, companies, when you heard from NanoRacks earlier as one of our implementation partners, and this growing community of on-orbit commercial facility operators. And working with other implementation partners that can enable new customers like Target to translate their experiments and investigations for the space station. So we're seeing these companies or implementation partners like NanoRacks bring in new payloads to the space station every year. And it's also more about space. So I was mentioning in terms of the unique environment, we emphasize that. I'm going to get into that in just a moment. But it's also more about the support, the project management that CASES provides to companies like Target, and really trying to translate that ground-based research to space-based research, also providing access to our crew or astronauts, and the subsidies that are available in terms of launch, transportation costs. All of those we provide in partnership with NASA. In addition, which is also pretty unique, is the marketing opportunities that we provide companies, that they love to be able to publicize and promote their investigations and their projects in their own unique ways. So why space? And you've been hearing about this throughout the day. Earlier I heard Erica bring up in terms of microgravity and some of the incredible research that they're working on for Blue Origin. And really those components, that having access to that unique environment, we emphasize three key areas. So of course, starting with microgravity or weightlessness. So looking at some of the phenomena that Erica was mentioning earlier. So you're looking at that lack of sedimentation, convection, buoyancy. What does that translate to in terms of the types of research or that fundamental science that you can look at and investigate on board the space station and bring that back to your product development processes or R&D on Earth, and the implications that can have in terms of cell behavior, organism health, fluid physics, combustion, et cetera. The second key area that we emphasize is the extreme conditions of space. You've also been hearing about that as well. The exposure to this extreme environment, the hot and cold temperature cycling, because we orbit the planet 16 times a day, every 90 minutes. So the temperature cycling that entails in terms of the fluctuation between minus 250 degrees Celsius to 250 degrees Celsius plus, and what does that translate to in terms of qualification of materials research or sensors or accelerated degradation, and other components or demonstrations that you want to have exposed, not just in terms of the temperatures, but atomic oxygen and radiation overall extreme environment. And thirdly, unique vantage points. So as I mentioned, we cover 90% of the Earth's population. The observations from the space station can provide unique spatial resolutions, variable lighting conditions that are compared with the sun-synchronous orbits of typical Earth remote sensing satellites that allow more insights in terms of diverse fields ranging from atmospheric modeling to agriculture to storm tracking. So I wanted to show you a few examples. There's some case studies of flight projects that also demonstrate in terms of the commercial innovation, some of the activities that we're seeing and the demand that we're seeing from various Fortune 500 companies and startups and other institutions. And I'm going to start with life sciences, focus on those three verticals: life sciences, physical sciences, and aerospace, and then with a little more emphasis on tech dev, since that's the portfolio I oversee. So life sciences, includes drug discovery, delivery, accelerated disease modeling, crop sciences, ag bio, organ bioengineering, regenerative medicine, protein crystallization growth, and really seeing how we can leverage drug discovery and delivery for looking at new targets for significant disease, creating new formulations for biologics. We worked with Merck recently, and they were looking at drug delivery methods for their anti-cancer drug Keytruda. And if you haven't heard of Keytruda, you'll know about it now because it's all over the TV. And they were looking at ways to create better methods of delivery for patients. I mentioned crop sciences, so Budweiser, we're working with them. They were interested in learning about how barley, various strands of barley seeds can germinate in microgravity. And the data from these investigations could influence how barley and other raw materials could be grown and developed on the ground. Materials and physical sciences, so moving over here, fluid dynamics, transport phenomena, when you were hearing about combustion earlier, reaction chemistry, nanomaterials research, and biofilms thickness and corrosion. One example I wanted to showcase is our partnership with Goodyear, and they're looking at silica formation for rubber products and attempting this formulation of unique silica morphologies in a microgravity environment where this research could potentially give them a competitive advantage, not just in the tire industry, but what does that translate to in terms of materials relating to rubber products across industries. Moving to remote sensing and aerospace tech dev, so looking at data collection, small sat deployment, Earth observation, or thermal management sensor development. And one example I wanted to show you is our hyperspectral 3D winds observation from low Earth orbit. And really trying to see how we can address using these sensors to address aviation, agriculture, oil and gas, environmental monitoring and forestry industries, and also looking at some of the impacts in terms of how can we look at smarter weather forecasting capabilities as well. And lastly, technology development and demonstration. So some of the areas that we're looking at in this side is anaerobic production or in-space manufacturing. IT, communications, such as artificial intelligence, optical communications, emerging tech, like virtual reality, or other data applications, robotics, electronics, and seeing how we can leverage being on the space station for this long duration space flight, and what the implications that those are for tech, or various technologies to test that in those environments. And what does that translate to in terms of products here on Earth? And a perfect example of that is our partnership with Hewlett-Packard Enterprise, where they sent their spaceborne supercomputer to the space station just last year, where they were trying to determine effects of solar radiation on performance applications, catching and analyzing data errors. They were able to consistently deliver over 1 trillion calculations per second, or 1 teraflop of performance, which is pretty remarkable. And everything is still going well with this supercomputer. And if it's successful, this demonstration could benefit other terrestrial computer systems, and in terms of future generation product development for their hardware and software. So we're really excited to see that. You've been hearing a lot about fiber optics today. I've noticed it was mentioned a few times, or ZBLAN. This is a very exciting area for us, and one of our main strategic areas, I should say, in terms of on-orbit production. So how can we enable more of these investigations? And I'm not going to go into the science specifics of it, since you heard about what we're looking to do in terms of creating that orders of magnitude difference with the product, and less impurities, less defects, and the implications that will have in terms of the medical industry or medical lasers, optical communications, and fiber optic components impacting these multi-billion-dollar industries. So really excited to see that with not just Made in Space, but we're working with other companies and startups as well. And robotics, one of my favorite areas. So we've been working with MIT and NASA Ames on the Spheres program. They've been able to successfully run these free-flying robots on the space station over 10 years. And now we're seeing the next generation of these free flyers called, or the next version of it is called Astrobee, where there's going to be more capabilities, sensor development, nav systems, camera systems, and other capabilities for instance, artificial intelligence. I'm sure you might have heard of other free flyers that have already gone up or that will be going up, and actually one is about to go up on this next launch pretty soon. And I have a quick video so you can see this is the prototype in the Gravity Lab at NASA Ames. That's Trey Smith, one of the technical leads for the program. So we're excited to see that. The first unit will go up later this year in the fall. And lastly, imagery and data for software products, also one of my favorite areas. We're seeing a lot of proliferation and a lot of interest from companies in this area, seeing how they can leverage our onboard camera systems, hardware for high-resolution imagery, Earth observation applications, and other tech demonstrations and product development. And one of the partnerships that we've been able to develop is with Google, and particularly for their software launch of Google Street View. And you'll hear about that right now. Yes. Can you hear the audio?
The sheer size of the space station.
Actually, there's no. Sorry, guys.
There's an audio check. Yeah.
I should have said I had. This is the only audio video I have.
This is it. Okay. This?
Yeah. I should have.
Try.
Yeah. Okay.
The sheer size of the space station, it's huge. It's unbelievably big. So I wish people could see it with their own eyes. But that's why in the future we'll hope to make it more accessible with projects like Google Street View.
We've mapped all over the world and really wanted to see where we could go, and why not space? what we're doing here is we're going to try to bring Street View to the space station.
In Google Street View on board the ISS, it will be a fantastic opportunity for everyone to fly with us and to experience the incredible feeling of being in space. So see you soon on board the International Space Station.
And that's still up on Google Street View's site if you guys want to take a look. And that partnership is continuing to develop in terms of upcoming phases, so stay tuned there. Again, just to bring it all back to what I was talking about at the beginning in terms of demonstrating our role, not just in terms of the Deep Space Gateway, but how are we maximizing this utilization of the space station, this incredible asset that we've all come together to build and demonstrate the incredible science, technology, and innovation to bring that value back to you here on Earth. So that's really what our mission is to bring that value to not just the U.S., in terms of the nation here, but across the globe, and leveraging the power of our partnership with NASA, commercial launch providers, implementation partners, and the non-traditional user community to maximize utilization of the space station and to bring that foundation to future orbiting platforms, future space stations, and commercialization beyond low Earth orbit. So hopefully, if y'all are interested to partner or to work with us, I'm happy to talk with you after. And if there are any questions, let me know. I don't know if we have time for questions, maybe one or two. But thank you again for having me, and thank you so much. Appreciate it. Maybe one.
Okay. The United States still does inches, yards, and miles. The rest of the world is metric. The space station is metric. So I'm asking, what's the cost of that dichotomy? And then my second question, is the best food still from the French lockers?
What was the last question? Is the French what?
It's known that the French bring the best food to the international.
I've actually heard that also Japanese bring the best food, and Russia's not too bad either. I think, or at least that's what I've heard from the crew. In terms of the metrics or measuring system, and do you mean that as far as what is used in the space station, or how does that translate to in terms of payload or weight? I know. Well, and that's not just applicable for the space station. I hear that just in science in general, where the U.S., because we still use inches, we have our own measuring system versus the rest of the world. It's not just applicable there, but I've seen both. So I don't know if the question is more in terms of the implications for that in relation to the financial side, or I'm trying to figure out the basis of the question.
The cost.
Yeah.
By the fact that what I'm hearing now is that the International Space Station handles both.
Well, we still measure in terms of the payloads for the U.S. because CASIS is the manager of the U.S. segment, the national laboratory of the space station. So we don't have any authority on any of the other sides of the or any of the other modules or sides of the space station in terms of the international side. So we still, pardon?
They're metric, though, aren't they?
Correct. Tough one, right off the bat.
Next question?
So you mentioned working with non-traditional partners, and a lot of the companies that you looked up tend to be more U.S. or domestic based. And I know earlier in some of the industry panels, there was some discussion about trying to branch out to other countries and stuff. Do you have this cases work at all with kind of bringing in non-traditional space countries, bringing them into being able to take advantage of these research opportunities?
That's a great question. So we, because of our mandate through U.S. Congress, with our cooperative agreement, we're only allowed to work with entities that are in the U.S. Although, because you see a company like Google or other companies in the world where they may be headquartered in other countries, but they have U.S. presence. And sometimes what happens there is because some of those companies are already engaging in that particular country, and it's sort of a pathway for them. We don't directly work with, in terms of governments or other, we're looking at, let's say, for instance, as far as the United Nations, where we're working with specific countries. But hopefully what we're trying to do is to lay that foundation to enable that opportunity in the future, or at least post space station. So, and I know that it might not quite answer the question, but I'm happy to talk to you more about it specifically afterward if you'd like.
I believe the part of your mandate at CASIS is to raise third-party funding, not just government NASA funding. How's that going?
Man, you guys. I would say it's going well. We're doing very well. Given the constraints that we have, given the amount of funding that we have, we're operating on a 0.00000 operating budget in terms of grants or seed money. And I think given that, in addition to, yes, we are able to leverage as far as the broader support, not just with NASA, but our other partners. I think we've been doing a pretty good job, and given the constraints or other constraints, not just from the funding side. And we're seeing that, as I was mentioning on one of the earlier slides in terms of the demand, we're seeing more and more of these companies where they're willing to pay, depending on the nature of the complexity or the type of project or investigation, research, et cetera. We're seeing that financial support from these companies as well. So, and that's continuing to grow. And that's really what we're trying to do, is to demonstrate that demand is there. That also then funnels to the rest of the industry, our launch providers or suborbital or implementation partners. Everybody will benefit. So I think, given, like I said, given the limited amount of funds that we've had, I think we've been doing a very good job. I'm happy to answer more later if you'd like to chat about it later. Thank you.